In the simple world of the climate alarmist, all you have to do to control the Earth's atmosphere is change the amount of CO2, increase the amount of CO2, and, well, hell breaks loose. So all we have to do to get back to peace and tranquility is reduce that CO2. Oh, if life was so simple. We'd have no ice ages, we'd have no change in climate. It's CO2, it's all that seems to matter. So what is this CO2? What is this powerful CO2 that only has 0.04% of the atmosphere, that is so powerful that it changes everything? Well, in this video, we're going to find out. But we'll start at the beginning. Well, we're going to talk about atoms and molecules, but don't worry, it's really simple. And we're not going to use any big words. CO2 consists of 2 oxygen atoms, and of course, a carbon atom. So the 3 atoms are joined together in what forms the CO2 molecule. You could reasonably ask, why am I telling you this? Well, bear with me for a moment and you'll understand why. So is CO2 a greenhouse gas, as claimed by the alarmists? Well, the answer is, yes it is. Well, as you know, kids, when they get excited, jump up and down, and this boy in doing that is certainly getting warm. Molecules are just the same. The atoms of the molecule have to move to store the energy. So when the sun radiates on the CO2, it absorbs and holds the energy. The atoms in the CO2 molecule actually move in 4 planes. It gets quite complicated, but there's no need to understand all that now. All you have to understand is, in practice, they actually move very fast, and in practice, they hold the heat. As the molecule absorbs more and more radiation from the sun, either directly or indirectly, the radiation actually has less and less effect. Technically, that's called a logarithmic scale, but what it means is that as you keep on adding more radiation, the effect on the molecule is less and less. Just like the little boy on the trampoline, the molecule can only take so much before it says, I've had enough. It's worth listening to the world expert on the CO2 molecule, Professor William Happer from Princeton University in the USA.
And as far as CO2 is concerned, which is the major focus, that's probably more good than bad.
Now, I can hear people yelling at the screen right now saying, what do you mean CO2 doesn't make much difference?
Well, you know, I know a lot about CO2 compared to most climate scientists because we make CO2 lasers, you know, and CO2 is a very interesting molecule. And the particular mode of CO2 that contributes to global warming, CO2 is a rod and it bends like this, up and down, up and down. And it's that bending motion that causes the global warming. But that is such a strong absorption that it's saturated now. So as you add more CO2, most of what you can do has already been done. There's still a little addition, but not very much.
Can you explain that to me in a little greater depth? What do you mean it's already been done?
Well, if you have a barn, you know, and you want to paint it red, you know, if you put a thin paint of red paint, it may not be quite red enough. If you put 2 or 3, then it really looks red. After that, if you add more red, it doesn't make much difference. And so that's sort of what CO2 is doing now, that most of the easy absorption has been done. And so as you add more CO2, you get a little broadening. I don't want to get too technical.
Well, no, I find this fascinating because, and the reason that I find it fascinating is that I hear that, okay, we've gone from about 320, 330 parts per million going back in the last 100 years now to just shy of 400 parts per million if we measure it in Hawaii.
Right.
And along the way, we've heard predictions of different catastrophic outcomes as we push our way through different maximums.
Yeah.
I haven't seen them happening, even though people will attribute some weather change to that. Yeah. You're saying that if we push through 400 and get to 500, the difference between 350 and 400 is greater than that between 4 and 500. Is that the? Am I right in kind of listening?
There's an interesting thing about CO2, which is unique to CO2. It's not true, for example, of water vapor or methane, and that is that if you get 1 degree of warming from doubling CO2, so going from, say, 400 parts per million for simplicity to 800, that doubles it. Mm-hmm. Suppose that causes 1 degree of warming. Then to get another degree of warming, you have to double 800, so you have to go to 1600. So you have to double it again. So it gets harder and harder to warm. Technically, they call that the logarithmic dependence of temperature rise on CO2 concentration. It was first guessed at, really, by Svante Arrhenius, who did some of the earliest work on global warming. He thought it was good, he was all for global warming. But he was the first one to point out this doubling property of CO2. Nobody quite knows how he guessed it. It's correct.
Because he wasn't using computer models.
Well, I mean, it was before quantum mechanics, he didn't even know about spontaneous emission. It was before Planck.
Okay, the physics lesson is over, but now we will take a history lesson into the fascinating history of CO2 on planet Earth, and I will explain why we need more of it. Although it may come as a shock to some, the Earth has not always been like it is today. It was once a molten ball. A long time ago, yeah, but a molten ball, and at other times it's been an ice ball. Volcanic activity in the past was huge, and it contributed huge amounts of very noxious materials into the atmosphere, such as sulfur dioxide, but it also gave a lot of CO2 into the atmosphere. And today, volcanoes maybe only represent a small amount of CO2 going into the atmosphere, but historically a huge amount. So the Earth used to have many, many thousands of parts per million of CO2 in the atmosphere, not the small amount of 400 parts per million that there is today. But coming from billions of years ago, we're now going to shoot forward in time to 540 million years ago, the start of the Cambrian period, the biggest explosion in life the world has ever seen. And that lasted for about 56 million years. But during that period, all the life forms we know today started, and they started in the sea, not on land. CO2 levels then were of the order of 5,000 parts per million. That's 12 or 13 times what they are today. But something very important started to happen, and that was the formation of creatures with shells. And those creatures with shells, when they died, trapped the calcium, trapped the CO2 in their shell. That formed things like limestone, chalk, and marble. Since that Cambrian period, 570 million years ago, life has trapped a lot of CO2 into rocks. Life has taken out of the atmosphere incredible amounts of CO2, gradually reducing it. You can see with the green line here how the CO2 has continually been taken out of the atmosphere until we reach current levels, which are CO2 drought levels. With life not sustainable on Earth, with CO2 levels of 150 parts per million and below, because no plants could live. It's amazing how close we got. About 18,000 years ago, it actually reached 180 parts per million. Just 30 parts per million above the extinction of life on Earth. What saved the Earth from total disaster then was quite a rapid warming period as we came out of the Ice Age. And that saved us, but it still only put CO2 to around about 280 parts per million, which was the pre-industrial level. In effect, mankind has saved the planet by putting CO2 into the atmosphere, because it's now increased from that 280 to around about 400 parts per million. Had man not done that, on this simple prediction here, in 2 million years, life on Earth would have ceased to exist as we reach the 150 parts per million level. Yet the entire thrust of the alarmist movement is to return to pre-industrial levels, i.e. 280 parts per million of CO2. Why? No one has ever defined what the right amount of CO2 is. There is just this wish to return to extreme drought levels for all our plants and hence the health of the world. Yet no climate scientist has ever defined what the right amount of CO2 is. It is totally illogical. But hold on here. If what I'm saying is true, the extra CO2 that we pumped into the atmosphere should have produced healthier plants, should have produced more plants, should have produced bigger food crops throughout the world. So let's examine what's happened by mankind's contribution of CO2. Now it's here where I need you to use your imagination. I want you to imagine that I come along to the world, from outer space if you like, and I say to the world, I can do something. I can actually take a desert. Let's take the biggest desert there could be. Let's take the whole of the USA landmass and double it. Let's take that as a desert. And as a deal, I'm going to add that not as a desert, but as lush vegetation. I'm going to add all that vegetation covering every square inch of the USA landmass twice over, and I'm going to add that to the earth. That would be a fantastic deal, wouldn't it? It really would. Well, the news is that's what CO2 has done. 32 authors from 24 institutions from 8 countries combined together to produce a report. They measured the extra vegetation on Earth using satellite imagery, and NASA published the results. And the results were that the Earth has produced an extra 14% extra vegetation in some 35 years. 70% of that extra growth they attribute to the increase in CO2. Just like you, vegetation has to breathe. When you look at a leaf, there are tiny microscopic holes in it that it breathes through, and it breathes in the carbon dioxide and gives off oxygen. Without the carbon dioxide, it wouldn't exist, because the vegetation, just like us humans, is made of carbon. Now, because we're in a carbon dioxide drought, those holes have to be large to get as much carbon dioxide in as they can. But as you increase the carbon dioxide, the holes can become smaller. Why is that important? Well, the large holes let out more water from the plant. And the smaller the hole, the less water the plant needs. And this is one of the reasons why vegetation is encroaching on deserts in the world now. In many parts of the world, there are shortages of water, and the carbon dioxide is helping towards resolving that problem. And by the way, don't be confused by the hole in the center of the leaf here. The holes we're talking about are microscopic. Of course, greenhouse owners have known about CO2 for years, and they've been pumping it into their greenhouses to make plants grow more. Now, the plant on the left is the ambient. That's what the current level of CO2 is, and that's the sort of growth you get. But when you increase the CO2 right up to another 450 parts per million, just over doubling, look at the growth you get. And really, we are truly in a CO2 drought. The Earth needs much more CO2 than it now has. And do not forget, the greenhouse effect of extra CO2 becomes minimal, which is why in Cambrian times you could have 5,000 parts per million or more and have no problem. Of course, crop yields per acre are increasing. And in fact, poor continents like Africa are now providing record crops. This fact would be humorous if it was not so sad and costly. This is the CO2 concentration in the atmosphere, and as you can see, it's continually growing. And no matter what conferences you have, Kyoto, Paris, Copenhagen, they make no difference at all, because the countries that produce most CO2 by far are not controlled by them. For all the hot air you hear in the UK about zero targets, it is all meaningless. We have not achieved any saving in CO2 in any event. All we've managed to do is export our manufacturing abroad where there are lower pollution standards, so we've increased pollution, and actually increased the amount of CO2. This is why this curve shows you that no matter what conference you have, no matter what you do, the CO2 is going to rise anyway. It's an essential part of life. And you know, that is good news.